Okay, so we'll start our lectures today. We have still technical problems, but I think most of the content that we're going to discuss today will be on the slides. I hope my laptop will be soon on, so we can switch to the laptop in case of we need to do some kind of demo. So this is lecture number 3. Last lecture we discussed Java basic of organization. Any Java program should be organized by writing the package name and then import some necessary package to complete your programs. Then we have a class, some declaration of the variable, then we have some methods. And we discussed Java basic keywords and data types, Booleans, integers, doubles, most of the data type we discuss. Identifiers, we discuss how we name the variable inside our project or inside our API, how we name the class, and also we discuss some kind of data type conversions. Today we will discuss about Android Studio app projects and also how the project is structured and some XML that will help you to build D1. D1 due date is this Friday. Also we discuss XML, some tags that are important for us, and also some layouts. After we finish discussing the project structure API, and then we go to objects in Java. So how we create object on Java, and what is the most important thing about Java is object oriented. So today is very important lectures if you really need to understand how objects are created on the Java and how you can interact with the objects. Start with Android Studio and exploring the project structure and layout. This is an example of a project called a student list. You can see there is a structures, the name of the projects, and then there is a manifest and Java directory, resources, res directory, and these are a lot of files. Okay, so what is this? So the first one and the most important one, maybe this course you're not going to go to Android manifest.xml and change something there, but if you are after this course, you got interested on how you can apply or change some configurations, some properties for your apps at the runtime. This is the location where you change it. I recommend you go and open one of these and see what is the content inside it. Now, you have the Java folder contain 3 subfolders. As you can see, we have the main folders that contains the activity Java file, and then any other model or any other Java classes that we're going to create inside the apps, we will find it also on the main part. Now you can see ca.yorku.ecs1022.student_list_app. The name of the app is student list app. So all these CA is a directory inside the hard disk. Inside it there is York, inside it there is ECS, inside it there is 102, inside it there is a student list, and inside that you will have the Java file called student STL main activity. That's the Java. And also we have another class called student inside that. There's 2 other folders that Android Studio created for us for testing and verification for the model. We're going to come across these files later on.
Those folders, .ca, .2, that's on Linux, right?
No, these are either if you work on Linux or work on Windows, the same thing. Java, whenever you create a package, you create a directory. And this directory will be created in your hard disk. Doesn't matter which operating system you are on. No, once you download the Android Studio and create an app, these will be created automatically. Now, there is a resource file. This resource file contains resources that will help you on the programming your apps. The resources, one of the resources is drawables. That's contain the images. If your app gonna display images or work with images, the images will be stored in this file. Then you have a layout. The layout, every activity, at least we have one .xml file that represents the layout, how the layout of your app will be. And also, we have values directory. Inside it, we have 3 XML files. One of them for the colors, the other one for a string, if you want to write your app for multi-language, and also the style that control the style of user interface that you added to your apps. This represents just the structures from outside of the app. If you go inside, you need to build an app, you need a widget. Then the widget is just, you can think about it as a view objects. Today we're going to see how Java create objects. So you think about widget is any user interface items that you add. You have buttons, you have checkboxes, you have text view, and you have edit text. And there is a lot also on the widgets that are already made for you. You can drag and drop on the view of the apps. You can do that, or you can write these on the XML file that is responsible for the layout. Now, there is one thing I would like you to keep in mind. These items, buttons, text, view, edit text, are called object view. So you can organize your objects in what we call a view groups. A view groups contains another view groups and also contains a view inside it. So we could have nested view groups inside your apps, and you organize the view inside these view group differently. We have also in the Android Studio what we call a layout managers. Layout manager is responsible about the size of items, view items that you add, and the positions of the items. Also, we have different layout manager you can think about. We have linear layout, we have tab layout, and we have relative layout, we have absolute layout, and frame layout. Linear layout organize view items horizontally or vertical. Now, most of the people, they find that linear layout are the easiest layout to work with because there is no relativity of anything, there is no constraint on the layout. You just organize the view items either horizontal or verticals. Table layout is organized in a tabular format. Relative layout is you have to make sure that the item is relative to each other. I encourage all of you to go to the Android Studio, create an app, and try to pick different layout and see how the effect of these layouts. We have list layout and grid layout, and the most one, which is the default when you create an app inside the Android Studio, is called constraint layout. This is the default one. So constraint layout, the default layout, and you have to tell that this item should be below this item, above this item. You have to add the constraint, and that is the mainly what was in D0. So all the work on D0 is about constrained the items that you add to the view to each other. Now, you can see on this images how the linear layout, you can organize them horizontally or verticals. The relative layout, you can give a space and size for each item relative to each other. List, you can list them. Now, which one should I pick? The one that is fit with your app. Sometimes you're going to see that in the app, you're going to pick 2 or 3, mix these types together. Because you can create a nested layout. You can create a constraint layout from outside. Inside the constraint layout, you can have a linear layout. And also you can have a table layout inside the linear layout. So you can create nested layouts inside each other. To create an interface inside Android Studio, you have 2 choices. The first choice is from the code. This is like a pure graphical user interface from Java. When the activity.java is loaded on create or before create, there is some triggering for some listeners. You can create your user interface item and add them to the layout. Or you can create your layout interface using XML. XML is a tagged language. It's not a complete language. It's similar to HTML, but it has open and end of the tag and organize things clearly for you when you are writing the interface. Most of the apps that you're going to create, you will have res file, and inside it there is a layout folder, and inside it you will see activity._main.xml. If you don't change the name, it will be default name is activity_main.xml. Inside this file, you will find XML language, and these tags like linear layout, text view, and etc. Before I proceed to XML, I want to highlight something about the interface, because I went to the lab and passed through and see some students, they are still struggling to understand the interface. Now, we said that we have the constraint layout is the default one. So whenever you create an app, you will see the screen like this. You will see hello world in the center of your app view. And there is some properties on the right-hand side, and this is the component tree, where whenever you add a new item to your app, you will see it on the tree. And you will see how the thing organized on the tree. And there is a palette here where you can pick up any user interface items you need to add it to the app. You can pick activity_main.xml. You can see the design, and also you see the text view, and this is the X view in the app. Now, you can switch between this very brief list of properties, or the most used properties that you can change, or the complete one. If you are trying to switch between the brief one to the complete one, you need to click on the double row on the bottom up right side. So you can switch now from the brief list to the complete list of the priority for any user items. And also now you can search for any property. You just type part of the name, you see the property, and you can change it. Now, if you have selected a layout, you just select the layout here. You can see that the layout has a few properties. One of them is how this layout is constrained based on the locations. You can see here the layout width and height are match the parent. So whenever you put the layout, it will match the parent in terms of user interface. Now, if you select just the text view here, you will see the properties here. The layout of the width will wrap the content and wrap the content. So exactly the bounding box around the text view will be exactly match the size of the text. Now, from the left and right, it will be constrained based on these figures. So it will have a same distance from the left and right and same distance from the up and buttons. So vertically is on the center and horizontally on the center. How the XML, this is the view, and if you press to view the XML will be like this. You see here, this is the tag, where everything will be inside the constraint layout. You open the tag and you close the tag at the bottom. That is how the XML. Whenever you need to open the tag, you put the angle brackets here, and then you write the name, and there is a backslash to close the brackets. Now, you can see here, these are the layout constraint from the top, bottom, off, parents. Everything here is for the parent because the text view was centered from horizontals and verticals. Now, you can change the view by going back here and make a constraint on these ones, or you can just type on the XML file. This is just we drag and drop this text view. As you can see here, this text view has some kind of size here and is not constrained to any side, either to the left or right or up and down. You can constrain using this view, or you can right click and add some constraint to the view. If you look at the XML for this, just the view, you will see it is very brief. We have the ID. It's good to give an ID or a meaningful ID for your user interface items because you need them when you refer to the Java code. And you can see the width on device pixels is relative to the device. Okay, you can say absolute pixel if you would like, but this is DPA's device pixel relative to the device. The text that is written on the text view is with the tag name is text, Android : text, and the name of the value for these properties. And also we have the layout editors absolute X. That means this text view has an absolute width and absolute height as a 50 dB and 38 dB. If we just constrain this text view to the top, that means we need the distance from this view to the top of the constraint to be 38. You can see the difference here. We constrain it to the parent, and this margin is the distance between the top to the view. So whenever we change from portrait to the landscape, this will be always constrained to the top. So either to do it on the using mouse, or you can go to the XML and type it. Any question? All of this is just to give you an introduction about Android Studio. I think most of you, if you watch the videos that we provided to you from Jackie or from Hamza Rahmani about the textbook, you will find all these information there. But I visited the lab and found that some students still struggling on understanding what is the interface of Android Studio and how they are interact to build just the view. We suppose all of you to finish D0, and now you are supposed to be almost ready for D1 because the submission for D1 is this Friday. I will continue today about XML file and interface tags. So XML is a tree of elements, and each element is child from another element. You can put them inside. So we have the layout of the widgets and the container that make the view. So XML has a property for each element. So you can see here, if you add a buttons, there is Android : text style dot equal bold, which tell us the meaning of what is the style of the text that will be written on the buttons. Will be a bold face. Now, all the elements on the XML are child from the root elements. The root element is XML from Android. You see this on the top of your XML file. This is the root XML namespace. So all the tags are inherited or taken from this root. Now, it's good to have the Android :ID for each attribute. If you don't do that, the Android Studio will generate a default ID for you. It's the best that you change this ID because you need it to refer to the ID user interface items when you are trying to code the Java. You want to interact with the text view, you need to change the text on the text view, or if you need to read something from EditText, you need to interact with these user items. If you are not able to identify these items or you generate the name default name, then you have to figure out what is the ID. Without the ID, you cannot interact between the user interface and the Java code. This is an example for defining the button. The ID is button, and the width and the height are as a wrap of content. So the bounding box around the button will be exactly match the text, the size of the text. Here, the text is written as buttons, and you can see here we have the constraint from the top to the end, and to start off and top off. Everything is parent except we have 0.5 as a bias. Most of the user group, view and view groups have the same attributes, and most of them, they will have the same thing here. They have the layout width, they have the margin from the top, from the bottoms, and the left and right. They have the gravity, which is indicate this item should be to the, you can pull it out to the left, you can pull it out to the right, or you can make it to the center. That is what we mean by a gravity. The weight is indicate how much space will be occupied on the layout. So if you have the layout, how much space of this on the layout. This is an example of make a difference between the gravity of the item itself and the layout gravity. You can think about it, when you create the layout, you mentioned that layout gravity is equal to center. That means everything, all the item that I'm going to put it inside this layout, they will be center. Now, also, you can specify the gravity for each item. So the text inside it, this item, or the text written on the button, will be center too. So you can have the gravity about the layout, that is what controlled by layout gravity, or you can control the gravity on the center for each items. Also, it's good to understand how the colors on the Android Studio. One of the ways to recognize the color is using the hex number for each red, green, and blue. And each number is ranged from 0 to 255. And from, on the hex, from 00 to FF. I don't assume that you will memorize all of them, but at least you have some colors that in your mind that's the default color. What is the red, what is the black, what is green, okay? So you can see here, if you have 255 for the red and 0 for the green and blue, then you will have red. So that's equivalent to FF00. If you have 0 and then FF then 0, that's equivalent to green. And if you have 00 and 255, which is equivalent to double F, that is what? Blue. Black is all 0. All of them is 5 is white, and these are the gray and other colors. These are the most will use the color, or these are the obvious colors like the white, the yellow, the red, silvers, gray, up to blue and black at the end. So Okay. If we look at the bottom, most of the XML tags that is related to the bottom is the ID, on click, and text. So these are the properties for the buttons. You have Android, then ID, you give the ID. These are the red where you can change this. The ID, it should be unique ID because you're going to refer to this on the Java code. On click, you give the functionality. When you press the button, what is the kind of functionality we're going to press? Is the procedures, Java code. Text is the type we write. How we can find the button from the Java code? You can find view by ID, then R represent the resource, dot ID, because you add here, add plus to the resources, and you give the ID, the same ID of the buttons, and you cast it to the button and return it to P. So you can interact with the button and change the text on the button if you would like. This is an example of button XML tags. You can see here we have a button with ID BTN capitals. The constraint of the width is wrap the content. The layout height is wrap the content, and the background is given as the number sign 000000, which indicate that the background of this button is a black. Now, what is the gravity? What the center of the text that's written on the button is centered. And once we click this button, we're gonna call the message or call the method is on click button. Now, if we look at the text, what is the text is written on the button is called Bosch. And what is the color of the text? The text color is number sign FF0000, which indicate it's red. This color is red. Now, what's the size of the color is 24 SP, that is absolute pixel size. And what is the style of the text? It's bold and italic, okay? And this button has a constraint to the parent in all the direction with bias horizontal offset 0.5. So the most obvious tags, I think you should know them. If I give you the XML, you should tell me exactly what's the ID of the button, what the text is written on it, what's the background, okay, and what is the color of the text. For example, here, this is the button, okay, and you can see here there's something I lifted out. I would like you to take, let's say, half a minute and figure out what is the value for this attribute. We have the button. The ID of it is PTNP, capital. That's the ID. The constraint for the height and width are wrap contents. What is the background of this one? The background is black, but to represent the black on Android Studio, we're going to use the hex numbers. And if you can see, all the values of the XML tags are as a string. You have to put them inside double quote. Okay? So the value here is as a string between two double quotes. So we assume that the value inside this box should be between double quotes, and the value should be represent the background colors, which is a black. And we know that we have red, green, blue, and each one of these colors represent by hex from 00 up to FF. If all these red, green, blue have a value of 0, then we have a black colors. So I assume here the value will be number sign 00000, but this is not the correct answer. Forget about the double quotes. We have to put this value inside the double quote, because all the values inside the XML, as you can see, is double quote as a string. So what is the text here? And what is the text colors? And what about the style, as you can see here? Take half a minute and try to figure it out. Okay, so let us see. So we have 000 for the background. Hello, I am buttons. That is the text is written here, is a string value. And then we have 00FF00, which is the green. And we have the bold as text style. Any question? If it's accepted, did you try it? Okay, so the good answer for your question is, did you try it and it's work? You try it, okay? Yes?
Why would like hard writing the XML like there's like the widget on the side of the way?
It's good to know what is the XML, the equivalent code. It's good to know the both sides. And
When you're making the app, it takes too long for you to like hard code it, so everyone uses
it's from different point of view. Some students, they will find they are familiar with XML. They find it easy to work with XML rather than working with a drag and drop with the cursors. From your point of view, it might be using a drag and drop of the mouse and organizing the layout you forget totally about the XML. That is the best way for you, okay? But some other people, they like to work on the XML file. And we in the class, okay? We are in the class, we have to know both sides. You need to know some XML tags, okay? And what the effect of these XML tags on the view, okay?
but XML would like retain some. It would make the work that we would do with XML like hard writing it, right? It would like have some pertinence to the lab test before, like I think 2 weeks from now, right? Like there'll be some XML involved.
Yes,
Okay. That was just called program.
yes. Now, if you work with EditText, you will have some famous XML tags like hint. You can add a hint to the buttons, to EditText. You can give an ID as the buttons. You can also control the input type. So you can force the user to make an input of a string or make an input of numbers that don't have a decimal points, or you can make it a phone numbers. So you can make sure that the user, when the user interact with EditText, only a certain input type are valid and acceptable. Otherwise, it's not acceptable, you cannot go. And also you can mention the lines, the number of visible lines inside the edit text, or you can say the maximum number of lines that the user enter there. And the text that is appear on the edit text and the text size of the edit text. Unfortunately, I don't think that this is working, but okay. Okay. So we leave this to work. Can continue here. So you can see this is one of the exercises that you have to do, is creating a buttons, and when you push it, you will generate a random colors. Okay? This random colors, you need to communicate back to the user interface and change the background color of the buttons. So you can see there, I hope it's visible. So this is the view. You can control this by, if you click on the right hand side here, you can constrain the item on the user interface. You can make it wrap content or the parent. You have list of values here. This is the XML that we talk about. It's exactly the tag. So I can do whatever I need on the XML side. I don't need to use the user interface to do that. But I believe most of the time in the labs, you're going to use the user interface. Now, it's good to know both sides, but I don't expect you to be expert on XML file at the end of the lectures. Okay? I need you to know Android Studio, how to develop an app, and I need you to learn Java programming. Up to right now, we didn't introduce too much about Java programming. Today we're going to do it, how to create objects on Java. So far we introduced how the Java program is organized. That's all. Now, to be able to do this, you can see here one of the properties for the button is saying that this is the text view. Here, this is the button. One of the properties of it is saying on a click, if I click this button, I will go to the Java and find out one of the thing is public method. Public method is called change colors. Now if I go to the main activity, this is the main activity of the program. The main activity, it's extended from app compact activity. We don't need now to go deep and discuss what is extend, because this is not a scope of the course, and what is the app compact activity is. The only thing that you need to know is the main activity is the class that Android Studio is created for us. Whenever we create an app, we're going to go to on create, and we're going to load this method. There is other method also in addition to on create, but we're going to just leave it like this. You don't modify it unless if you need something to be set up at the beginning. I'm going to show you at the end of the lectures when we see the student list app that we create. So there is a method, it's public, void, it will retain nothing. The scope of it is public, that means everybody can see it. Okay, that's why we need to make it public. If you need to link something to the button, you should make it public. You cannot make it private, because the user who's going to use your app, he needs to press the button and then go to this method and do the procedure. So if the procedure is labeled as a private, you cannot link it to the button. You link public methods. And this method is retained void. The name is change color, which is the match, the XML tag. If there is mismatch, there will be a problem on the compilation and building this app. Now you can see I use math.random. Math.random will retain a random number between 0 and 0.9999. 1 is excluded. Now I take this number, I multiply it by 256, and then I round it to integer. Then I assign it to integer red. Then I have the same thing for the green, the same thing for the blue, and we have to create now a percentage of the color. So we have how many percentage of the color times 100, that is double type. This percentage I will display it for the user. So this background contains 20% of red, 30% of green, and then we have the rest 50% from blue. This is how we do this exercise. We talk to the text view by using find view by ID. I show you that sometimes we need to create help methods. Help method that we can use it every time. But here, because we are going to talk only with one text view, so we are using directly find view by ID. R represent the resources. One of the resources that is available for us is ID resources. Where is these ID resources is clear here on the XML. Here is the ID resources. This represent add to the resources plus ID. This is ID resources that we have. We have at drawables. That means resources for drawable items. We can have images there. So here ID resources. And then we're going to talk to label, the name of the ID. I give a label, the ID of it. And then we cast it to text view. It's very important to do this manually, to do the casting manually to text view. And then we have a text view. Now we format the string. In the textbook, there's more detailed information how you can format or type the string. I'm not going to go deep on it, so I left it for you to practice. So here is the R string, R equal. Then you have a %, dot 0up. That means I don't need any decimal points. And then the first one is R. R is a double. So the first one organized with the %. So whenever you have this %, that means you are gonna replace this phrase with some value. Here we will just type 0 decimals. Then we have the green and we have the blue. Then we put TV, which is the name of the variable is text view dot set text. This is the method to set the text is equal to the string. Then we have to create an object is called color dot. We create the objects and we talk to the buttons, we bring it and we change the background of the buttons. This is how we do the app. If you want to run the app, we're going to ask the app to be run here. But I added to the slide is the result of running this app. Sometimes you're going to see whenever you modify the app and you try to run it, the app is crashed. It's good sometimes to build the app. There is an option to build it before you run the app. So I will leave this to run. We'll go back here to the slide. So you can see here on the slide, okay, this is the way that we put the string, and this is the method. You declare the variables. You generate it from math.random. Okay, you multiply it with the numbers. Then you create a color object. Then you set the background colors. Okay. Now, that's all about this app. Now, it's good to have this method on your apps. You can copy them. Whenever you create an app, you add this method. It's a helper method. As you can see, the header is private void. That means it's a private. Only within the app we can access. User from outside cannot access this one. This method is allow you to interact with text view. So I can send any ID for a text view, and I can send a new content for the text view. I can find the first statement here, find the text view, cast the text view, then change the content of the text view. It's good to keep this method inside your app as a private, as a help method. So all these 3 lines, you need them if you decide to change the content of the text view. So rather than repeating this line over and over in your code, you can put them in a helper method, and you can call this method whenever you change the text view. You just set content of the text view and you give the ID. Okay, that's good. So now we have the app. When you click it, you change the color of the, and you print the percentage on the screen. Also, you can have these helper methods in your code whenever you need to get a text from EditText. These lines, you need to repeat them over and over whenever you need to interact with EditText. Find the EditText, cast it, then retrieve the string content of the text, EditText, and return it to the user. If you want to clear, sometimes after you press some buttons, you need to clear the content of the text view. This is another help method. You clear the content by text view by sending an empty string to the text of the text view. Any question? Yes. This one? Okay. So how many of you already finished D1? Did you submit it to the TA? Did you use submit? Did you recreate the project on the lab environment? Okay, let me ask a weird questions. How many of you are still struggling of going to the lab and run the Android Studio in the lab? We have to use Android Studio. So you have to use Android Studio in the lab, because the lab test you're going to use Android Studio.
I have no problem with the model, but then sometimes the view and the layout.
Not on your machine, on the lab test, on the lab environment. There is a TA. I already put in the Moodle the name of the TAs and the email of the TAs. The TAs, you have 3 hours. Try to be on time, okay? And also you can ask the TA any help you need using the Android Studio on the lab machines. Now, if you have struggles on your own machine, we recommend you to install the VirtualBox. Now, if you struggle in the VirtualBox, don't waste your time. Stay with the lab. Sometimes the labs there's a free time. There's no scheduled labs. Even you have 3 hours every week. This is reserved for the students of this course to go to the labs. The Android Studio is installed in almost on all the machines, not only in Williams Small Centers 106, 108, and also on the SAND 102. But you can find it in 106, I think, if you have it free there.
Where exactly do you go to get the laptop in the Prism lab to rent them?
Yeah, in the Prism lab.
And then you rent them, and then you could because I did it once, and then I did it. I wrote the code, and then I put it in compressed zip, put it in Google Drive, and then brought it up, and it worked.
No, you have to ask the lab mentors. If you borrow a broken laptop, you have to give it back to him and let him give you a working laptop.
No, you can't use the code that's used on this computer because it's Windows, right? So you need the same environment.
No, I already mentioned in one lecture how you can transfer the code. You need XML file, the layout.xml, and you need Java file. These doesn't matter if you are transfer these file from Linux, Windows. These file you open them, you copy paste. So you create the project on Linux, okay? You have these files from the Windows, like this machine is Windows, so this file doesn't matter where I have them. So you have to not move the project all. These are the files that you need. Only XML file. I'm not going to waste too much time on this. I already talk about it and explain it. So if you still have a problem, this is the Java file. Java file doesn't care if I write it on Linux or Windows. So if you still have a problem, talk to your TA, or you can see me in the office hour, I can show you. Okay? Any other question? Yes? When you are using text view. Text view, if you want to send a message to the user, you can write a predefined message, a message on the top, or a label to the edit text. For example, you need to let the user know that this edit text is for entering your name. So you write a text view, enter your name next to edit text. Or you use a textbook to display something to the user as you saw in this app. I display the percentage of the colors. So text view, you can use it to write a message to the user or to give a message in your app to the user. So to interact with the user by sending messages or writing a message to that. Edit text for user input. If you want a user to input his name, you use edit text. So you can interact with edit text by fetching the content of it. Any other question? Okay, so now we will talk about Java, object-oriented programming. What is object in Java? Why we call it object-oriented in Java? Let me just start running this app for you. This is very simple, and I think we can start modify this app later on. So in this app, I create a class called a student. When I create a class, I call public class student. So it's visible for everyone. Everyone can see this class. A class in Java means object. You create your own object by creating a class. That is the beauty of Java. So whenever you use a class to create some data type or some object, so we can say you create your own data type using the classes on Java. Here I create an object or a data type of students. What is inside this data type and what is the properties and what's the feature of this type? We have only two features. They are a private string, the name of the students, and the ID of the students. So this data type called a student, it has only two properties. It has name and has student ID. It's recommended in the programming, whenever you create a class, you have the attribute of the class as private. Because you don't need a user from outside of your program to interact immediately with this attribute and change them. You provide a method. That's why we have a method, a behavior of this data type, a behavior of how I can change the name, how I can set the name, or how I get the name. In this case, in our case, actually we not allow the user to set the name. We can set the name when we create the object. So once we create a student object, using a constructor is another keyword. What is the constructor? Constructor is a method. The name of the constructor, the name of the method is the same as the name of the class. So we have a class of name student and we have a constructor of name student. We can have many constructors, and we can have 0 constructors. If there is a problem when you have a 0 constructors, because if you don't provide the constructors, the Java will automatically provide no argument constructor for you, which is a risk that you're going to take. That's why I recommend you, whenever you create a new data type or you create a class, you provide a constructor. You have to make your mind, I need a constructor, and what is the shape of this constructor? What is the argument of this constructor? You don't have any choice to rename the constructor. The constructor is because it's named constructor, because the name of the constructor is the same as the name of the class. So we have here only one constructor, student, public. There's no retain type here. I didn't put a void next to the constructors because it's meant to create an object. It will retain nothing. So even if it's retain nothing, I don't need to put a void. It's a syntax problem. The compiler will stop you. So public, student, and what is the argument? I have a string, name, and I have int as an ID. Then I assign the name to the attribute of the students. We say that we create a data type of type students. The attribute name and ID, I just assign them now. This is the final assignment. Nobody can change them after that because I didn't provide a set method to create them. I provide a get method. If you would like to know the ID, you use get ID. If you would like to know the name, you use get name. And I will retain a student name for you. And you can see the get method, they are public. So everybody can use them. So get name and get ID, they are public and they have a retain type. You retain the ID, retain type is integer. Then we have toString. If you would like to print something to the user, I'd like to print a student as a text, we use toString. Okay? toString is a method that allows us to print and retain a string representation of the objects. So here we retain a string, a student I, name, plus, then we have double tab, then brackets, number sign, then close the colon, plus student ID, then plus close the bracket for the students. So this is a class, a very simple class I created. In this app, I will ask the user just to write the name and ID and save. Then whenever I press save, I will create an object. I will add this object to the list. So I can add many students. Then I will ask print the list. See me how many students I have. So I have the button here linked to a method called onSaveClick. So where is this method? This method is written here on the activity. Now, I would like you to see here, I modify the main activity. I add public list, a student list. Okay, we're going to come to the how we define list later on the course, but this is how we create a dynamic list. It can be extended easily. There's another type of fixed list, which is array. Once you create it, you cannot change the size, okay? But here is the dynamic one. You create a list of type of students. I create a list. What kind of things I'm going to store inside the list is a student type. It's called array list of type a new array list. Now, I interact using the private methods to set and get a content and even clear the content here. Once I want to save the students, so I enter the name of the students and the ID, I press save. So save is linked to this method. This method will read the content of the to edit text box, text edit text, which is the name and ID, and then they change the ID to the integers and change the student name to the string and create an object for us. You can see here, this is the sentence where we create an object. This sentence, we create an object of type students and we assign the name of the students and the ID of the students entered by the user. Whenever you need to create an object, you need to use a new keyword. You need to tell the Java, I'm going to create a new object. Now, you can print the list using onPrint click, and this is a demo how this app is working. So, let us dig deep now on the class and Java after I give a brief overview about the objects. So, object in Java is something integrate the state and the behavior. You declare a student as a type. You say, I am interested in the name and ID of the students. What is the behavior? You can get the name, you can get the ID, you can print a string representation of the students. So this is the behavior. Maybe later on I am interested to add more methods to the data type. So objects is a concept where you have the state and the behavior both together you can merge them or integrate them together by defining a class. A class is a template. When I say I'm going to create a class of a students, that means I create a data type similar to double. You can have double as a data type. In Java, you define many variables of type doubles. The same thing, you create a class of a student. You can define many students objects from the same class. So when you create a student A, student B, student C, you know that all these students, they have the same state and they have the same behavior. So the class represents a template or a common structures for your data type. So when you decide to create an instance of your data type, you use a new operators. You say students, a new student. You create a new object. It's not creating a new class. You create a new object from the class. We call it instance from the class. So when you create an instance from class, you can change the state of the class. So the student A has a name A, student B has a name B, but both are from the class of the students, but they have different state, different names. Now, to be able to create an object, you have to use the constructor. Constructor is a specialized method that acts as a factory where you can create an object from the class. You cannot create object from a class that doesn't have any constructor or has a private constructors. So if you have a class with a private constructor, so no one can create an object. Like the math. Math is a utility class. You cannot create object from the math class. Math is a static class. You cannot create object from the math. In our case, we have public class is a student. We provide a public constructors to the user, so the user can create an object from this class. In Java, the constructor always has the same name as the class. So you cannot say, I have a constructor, the class name is a student, and the constructor is with different name. So the constructor name should match with the class name. And you have to use a new keyword. Yes. Yes, you can have as many as you want constructors. Okay? Because you can construct the object in any different way you like. Yes.
So if you have multiple constructors, do they all have to be the same name?
That's right. There's no problem. The name of the constructor is the same as the name of class. The difference here, the list of the argument, the signature of the constructor, which is the list of arguments that follow the name of the constructor. We're going to come to that later on about the signature of the method. Java, one of the languages that they have what they call a garbage collectors is automatically. Whenever you're not referring to the object, Java will destroy it for you. So you don't need to provide deconstructors like C++ or C. But Java allow you, if you are a professional enough to build deconstructor, they allow you to do that. But it's recommended to not go there. So just leave Java work by itself. It will destroy any object is not necessary for your program. Yes?
Can you use one object of one instance of a class in another class?
Yes.
And would we need to do it inside the app?
Yes, we need to do that. If you want to, like, let's say you have an address as an object and you have a class of a student, you can use the object of address inside this class, okay? You can have a class object inside other class, okay? But in this course, we're not going to define what we call a nested classes, that the class just declare a nested class inside it. So whenever we define a class, there is only one class on a file, okay? But objects can be used inside other class as an attribute or as a field. So this is the class, is called public class for student. This is the documentation. Is normally, it's good to have a documentations. These documentation later on you're going to see in the other courses, this will be represented as an API. If you go to the I2C jar files that you always add to your apps, this API information is coming from the documentation here on the class. So you document your classes. Now, this description go for all the class. The name of the class is public class students. Okay, this is the header of the class to declare the object of or the class of type students. We have two attributes. Two attributes, one of them is type string, the other one is type int, and both are private attributes. We have a constructor, public students. There's no retain type. I mentioning that again. There's no retain type for the constructors, not even void. So public students, and we send name and ID, and we assign the name and ID to the attributes. Now we have a get method that is retain the attribute to the method, and if we have more get methods, that we call it a getter methods. Okay, getter methods, or we retain the value of the attributes using get. Always the get method start with get the name of the attribute, get name, get ID. So that will help the user to work with the methods. Why we have to write get, why we have to define integer as an ID? It's based on the designers. If you are a designer and you think that the ID should be string, so you change the attribute here at the beginning and you say, I have a student with name as a string, ID as a string. It's back to the developer designer. For me, I decide that any ID should be a number, not a decimal numbers, so I don't decide doubles, like 1.2, a number of students, okay? Some people, they say, okay, the ID contains text and numbers, so we decide to make it string, okay? But in our case here, the ID is integer. It's developer decisions. This is a string representation for the app. It's good to have two string representation in your classes. Whenever you define a class, it's good to have two string inside your class to represent. So using how I can use the student class, I define the student's class, how I can use it. You can use the student class by creating an object. As you can see here on this slide, we use students, like double data type. Now students has become like leftmost. This is the type of the variable. What's the name of the variable? stda, capital. So the type now is students. I create a class. So whenever you create a class in Java, you create your own data type. You create your own data type. You can interact now with the students as a data type, as you interact with the string, as you interact with the double and int on the previous lectures. So students, stda equal new student. Now, equal new, I'm telling the Java compiler that I need a new object. Please make a space on the memory for a new student object I need to create. Now, because we have a constructor for a student class, and this constructor tells us you cannot create a new object from students without providing the name and ID of these students. So that's why in the constructor, as you can see in the slide, I give a name and I give the ID for this student objects. So now we have a student A, name of the variable, pointing to a new object is created on the memory with the name student A and the number 10056. Now, you can create another student P, the same method. A new student, you give a name and you give an ID to that student. Now, in your class, D1, you're going to create a model, BMI model. Is you create a type, BMI type. So you create a public class, and you can see here, you have a private 2 attributes. So the data type that you create in D1, its name, PMI model. That is the type. What is the attribute of this type? Weight and height. What is the type of this attribute? You decide they have to be double, and they have a private. So no one from outside can access these attributes. Now, you decide to have one constructors in D1. What is this constructors? You have to send the weight as a string, and you have to send the height as a string. And inside this constructor, you're going to deal with the problem of converting a string to doubles. Then you assign it to this dot weight. This is a keyword always pointing to the object that is being constructed. So this here, this is pointing to the object that you decide to create in this case. So the object is being constructed right now. This, you can use this as a keyword to point to that object. So you say this dot weight. Because you are within the same class, you can access these private attributes directly. So we can access the weight and the height directly using this dot weight, this dot height, and then we convert the string to doubles. And we have one method, the behavior of this BMI model. So these are the attributes. These are one of the behavior. So what is the behavior of this model, that new data type that I create in D1? I said I have public, I will retain a string, get BMI, it will do some calculation and will retain the result to the user. So this is an example of creating a new data type using a class. So the Java will allow you to create your own data type. Okay? Any question? Okay. So this is the constructor to set the instance variable. Yes? They are private, yes? You cannot access these private double weight, private double height from outside. Okay? You cannot access them from outside. But you can access them using this from inside. Okay? This is the method to calculate and retain. This is the way For example, here, I cannot say my model dot weight. This is the main method, okay? This is the main method, will be actually inside the class, but you cannot access by saying here you create, you see here, you create PMI model, you use it as a data type. Now, because I create a class, a new data type, your own new data type, then my model equal new PMI model, and you give the values, the height and weight as a string. You have to be matched with the constructor. The constructor say, I can construct the PMI model, but I need to receive the height and the weight as a string. You cannot send them as a double. So you have to match with the constructors, okay? Now, if you need to send doubles, then you create another version of constructors. You can have 2 or 3 constructors with different arguments. So I have the name of the model is my model and is pointing to a new PMI models. Now, here I cannot say my model dot weight. I cannot do that because these are private. Main method cannot access these private ones, but I can access dot get BMI. Why dot get BMI I can access from outside? Because it's a public method. Okay? Any question? It's recommended whenever you define your own data types, you create the attribute as a private and you provide get method and set method to change these attributes. We're going to see that later on also. Okay? Now, you define your own object by using a class. So the class is defining the type or category of things that is you need. For example, here I create a class of address. So any address, I'm going to use it inside my program, will have these things. Name, integer, the number of street, and also string, the street name, the city, and the province, and also the postal code. So I merge all these attributes together in one data type called address. So I create my own data type called address. I'm going to use address in my program. Whenever I use address in my program, it will contain all these informations as a one unit. So I merge them all together in one unit. Now, the object represents a multiple piece of information that are grouped together, as you can see. So this information inside the object, there can be a primitive data type, as you can see, double, integers, okay? But also they can be another objects inside. A string actually is another data type. A string here is an object data type. So object data type, I can put it here. Also, I can take an address and put it as an attribute for a student. I create a class of students. They have name, ID, and address. And this address will be of data type address. Yes? Yes. If you're not providing, I assume here everything is public, okay? When I'm not providing, we remember last lectures, we discussed that if you provide public, what does mean, private, what does mean. If you left things without providing anything, you will get a default access modifiers. Yes. Public. Yes. No, public of the class, that means everybody can see this class and everybody can interact with this class and create an object. Here I didn't provide the complete things. I can provide a constructor for this class as a public. Yes, the attribute is private. No one can change the attributes from outside, but I provide a constructor that is public. Everybody can create an object. I provide a get method. Everybody can change see the value of the attribute, and I can provide a set method, like the previous example. Okay? You can have a class, it's a public, and all the attributes are private. That's okay. That's safety for you, security for you. You provide another extra methods to set and get these attributes. Okay? So you need everyone to follow the rules if they want to change the name on the address attributes. Okay? Or you can say, as we discussed on the previous class, students. You cannot change the name of the students once you create the object. You create a student with a name. I cannot change it. If you want to change it, you have to destroy it and create it again. Okay? So that's why sometimes you need to restrict the way of creating the object and modifying the attribute of the objects. Yes, that's right. That's right. So once you construct the object and you have one of the attributes as a public, that means you allow the user from outside to access these public attributes and modify them directly, which is you have to take the risk. Okay? So the attributes can be primitive data type or can be another object inside it. So the object is bundling the data together, okay, putting everything together. This is an example for you. As you can see, I create an address, okay, then I create a new address to say that I want to create a space on the memory for the address. I can go directly address.name and change the name of the address. I can change the street number directly without any method because the attributes are available for the user and the user can access this attribute directly. So just dot city and I can change the city. Okay? Dot province, I can change it directly. So I create the object here, new address, with using no argument constructors. The constructor here in new address has no argument. We call it no argument constructors. I create an address object, I put it in the memory. I know I need the name, a street name, a street numbers, city, province, postal code. I need all of this information. But right now, I just create address objects. When I say I need a street number, that will go and change it on the object itself. So when I create an object with no argument constructors, it's the same. I reserve some space in the memory for that object. Then later on I change the attributes. Now the attributes are public, so everybody can interact with them and change them. Yes. Actually, I can say it's default access. I cannot say public certain. It's a default access, which is the package access within the same package. Any other question? Okay, so this is very important. You're going to go back after this lecture to some textbook or some references or some internet resources. You're going to see this. The variables and the methods that you define inside your class, they call it the members of class. So the attributes, the name of the attributes, and the name of the methods. Now, the variable inside this object, some people they call it fields, data, attributes, instance variables. So here, for example, the name, we can call it instance variables, attributes, fields. Okay, all of these you can name it. So fields, data, attributes, instance variable. So all these 4 keywords referring to the same thing. So if you go to some reference on the internet, or some reference on the library or go to the textbook. So the fields, data, attributes, instance variable, they are all the same things. Okay? Methods, we only talk about it as a method or a behaviors. Okay? But method and variables together, we call it members of the class. So generally, any fields or any attributes, any instance variables or any data you define inside your class should be private. You cannot see these from outside the class. You provide a getter method or setter method. Getter method to get the value, set method to set the value. That's why we call them getter method and setter methods. Now, constructors are used to initialize the fields on some predefined state. Like, I want anyone who would like to create an object of a student. He cannot create this object of students without providing the name and ID of the student. That's why I provide only one constructor on my class where the name of the students and the ID should be provided. Okay? So the constructors allow us to create an object and initialize the variable on a predefined state. Now we can allow the user to change this state by using get methods or set methods, change it, to allow the students to get the information from these attributes by get methods. This is an example of a class called circles. It has 1, 2, 3. We have X, Y, and R. They are center of coordinates and they are a radius of the circles. Now they are doubles and they are public. That means I allow the user to interact immediately with these attributes. Now, these are data attributes, X, Y, and R. We call it data, attribute, instance variables. Okay? All of them is the same. We have defined two methods, public double circumference to calculate the circumference of the circle, and also public double area. And you can see the body of the method. The body of the method, there is only one statement on the body of the method. Retain 2 times 3.14 times R. Now I can use math class, math.by, if I would like, but I hard-coded, which is not a good practice, to hard-code this constant, which is 3.14, which is a pi. It's good to use math.by, so I need to import the math class in my program, but now accept this one from me as hard-code for the pi, 2 times 3.14 times R. I calculated the area, pi times R squared, and I retain the area to the user. You see the retain type for both methods. These methods, we call it behavior of the object. So I create a class of a circle. That means I create my own data type called circle. What is the attribute of this? X, Y, which is represent the centers, and R, which is represent the radius. I have two methods. Now, you can see here, where is the constructors? I didn't provide any constructors. Even if I didn't provide any constructors, Java allow me to create an object because Java will implicitly give me an empty constructor, no argument constructors. So I can say a circle, A circle, a circle, P circle. So I create two variables, A circle, P circle, of type circles, because I create my own data type right now. Now, these are referring to nothing. When I say A circle, P circle in my program, they're just the name of the variable. They refer to nothing. They refer, you can assume they refer to null, or what we call it a null reference. Very, very risky in the apps that you're going to create and have something like this, a null reference. So by just saying a two statement like this, I didn't create an object that I want you to keep in mind. I didn't create an object of type circle right now. I create a reference that I can use it later on in my program to point for an object of type circle. But right now I didn't create any object. I just create a reference or a variable name that I can use later on to point for an object of type circles. You can say, I have a null reference now, but this null reference of type circle. So this is the declaration type. A declaration type of a circle is circle. Now, if I use a new keyword, now I create an object. Inside this object, I have attribute and the methods. So I have here dot dot, that means continue. So this, it has now an object in the memory. I have the object in the memory in new circles. As you can see, I use constructor with no arguments. Okay? So I have now an object circle in the memory. I can access X and Y and R. I change the value later on using a circle. Any question? Okay. So in the summary, the class is user-defined types that contain attributes, and these attributes, we call it variables, instance variables, attributes, or fields, and we have some methods that we call these methods as a behaviors methods, and an instance of the class is represent an object when you are using a new operators. How we can declare a class? This is the syntax to declare a class. You have to provide the modifier for the class, and you can, I put a star because you can leave the modifier off, so you can use the default modifier or access modifier, but it's good to have public or private class as you want. So modifiers, public, private, class, you give a name for the class, you declare some attributes, and you declare some constructors, and you declare some methods. This is an example of a class, public class, counters. You have a private int value. These are the attributes of the class. You have two methods or two behaviors. One of them is increment the counter. We increment the value, and the other one get the value, retain the value to the user. Now you can see here, I didn't provide a constructor, which is a problem. No one can now change the value. Okay? So to be able to construct the counters, you need to provide a constructors for this. Now, how I define the attributes or fields? I define attribute like this. This is the syntax. Modifier, public or private attributes, the data types, then attribute name, then the initial value of the attributes. You can see here, this is a public class FO, and you have a private int X, and you have a private float F, and you initialize F as 0.0. And also you have a strings name as a private, and you can initialize it with any string you like. Now, things need to be clear that we have type of a class, they call it a static class or utility class. These classes are statics, and all the fields in this class are static. So this class has an empty private constructors. Why someone will create a class that are empty and private? Why you are creating a utility class with empty private constructors? Can anyone give me a class or an example of a static or utility class that he worked with so far, or he saw us working with? BMI is not a static because you can create an object. You remember when you are importing the Java to jar files, you are using utility class, okay? Now, let me just give you one more clear example. The math dot cosine, math dot sine, math dot by, math class, it's created for us by the Java expert. Java expert create a math class for us. Now, this math class is a static class. No one can create object from it. No one can mess around with this. So it's a fixed and final class. And it has some methods that we can interact with. Like, I give you the angle, you give me the cosine and sine and tan for this angle. I ask you for a constant of pi, you give me back the pi. But I cannot create an object of math. This is an example of a static class, okay? No, you cannot. No one can change it. This is one of the security things. You're gonna see more if you take 2030. There is more discussion about the static class and utility class, why they are there. But for this course, I would like you to know that if you define a static class, you cannot create object from this class, and any static class will contain empty private constructors. But for this course, most of the time we're going to create non-static class, a class that we can create object from it, like BMI model. BMI model is not a static class, so we can create object from this class. So we have create a class, we can create our own objects, or each object has its own copy of non-static fields. So once you have non-static class, that means you have non-static fields or non-static attributes. When you create an object, like you have a student, A, the name of this student, A, the ID is 1. You have a student P, the name of this student is P, the ID is 2. So you can see student A, student B, they are from the same data type. Your own data type is student, but they have different state, different name, different ID. So it's good also to imagine that each object that you create from class has its own version of method, even if that is a fixed. But it's good to have the complete pictures here that you have your own copy of attributes, on values for the attribute for each object, and also the same methods. Okay, so here is just a diagram that shows that whenever we refer to an object inside Java, we are referring to the state plus behaviors. State that represent the value of these attributes, and the behavior represent how we can interact with these state. Now, a class is like a template. You create an object from the class by instantiate the class. At runtime, you create the object and you simulate the reactions between the class, like get the name of the students, get the ID of the students, you create the student ID, like you create the circles, you calculate the area of the circles. All these are behavior method you interact with the objects. This is an example of a rectangle class with a static. So you can see this example from your textbook. You create a rectangle class and they have a static methods. So whenever you have a static method, you can call this method from the name of the class. You don't need to create an object of rectangle to use get area. The same thing, to get a circumference of the rectangle, you don't need to create an object of rectangle. Why? Because the methods are declared as a static. Public static int get circumference. And you retain the value to the user. You can see here on the main, I can use rectangle, the name of the class, dot get area. Why I can use this? I didn't create any objects of rectangle. I can use the name of the class because the get area is a static method. It simply take width and height and calculate the area. So calculate the area using a rectangle, which is the name of the class. So whenever you have a static attribute or a static method, you can interact with a static method and static variables with the name of the class. You don't need to create an object to interact with them. This is another example where you declare a class called rectangle and you have a state to represent this class. It's not a static class. So you have a private width and a private height as an attribute. You have a constructors that initialize the width and height of rectangle. And once you initialize them, you cannot change them. You can calculate get area and get circumference for this rectangle. And all these methods are non-statics. So I cannot interact with these methods without creating the object of the rectangle. You can see the difference between this slide and the previous one. You need to create a rectangle r equal a new rectangle and initialize the new object with height and width. Then after you create an object, you can interact with this object by asking how much the area and how much the circumference for this rectangle. There is a difference between the static class and the object class. Static class, I can interact with the methods without creating the object. In the object class or instance class, I cannot interact with the method without creating an object. I will stop here and we will continue next time. Already you have the slides, so you can have look at the slide